Hello all, welcome back to my channel. Today we will be discussing the chapter Mechanical Properties of Solid, class 11. So first we'll be discussing about the intermolecular force. In a solid, atoms and molecules are arranged in such a way that each molecule is acted upon by these forces are acted upon by the forces due to the neighboring molecules. These forces are known as intermolecular forces. In this slide we'll be discussing elasticity. The property of the body to remain its original configuration, length, volume or shape when the deforming forces are formed is called elasticity. The change in the shape or size of a body when external forces act on it is determined by the forces between its atoms or molecules. These short-range atomic forces are called elastic forces. In this slide, we'll be discussing about the perfectly elastic body. A body which regains its original configuration immediately and completely after the removal of deforming force from it is called perfectly elastic body. Quartz and phosphor bronze are the examples of nearly perfectly elastic bodies. In this slide, we'll be discussing about plasticity, the inability of a body to return to its original size and shape even on removal of the deforming force is called plasticity, and such a body is called a plastic body. Now let's discuss regarding the topics elasticity and plasticity. Elasticity is the deformation which disappears with the removal of the external forces, whereas plasticity is the deformation that does not disappear with the removal of the external forces. Another main difference between the perfect elastic and plasticity is a linear problem and a non-linear problem. Now, in this slide, we'll be discussing about stress. Stress is defined as the ratio of the internal force F produced when the substance is deformed to the area A over which this force acts. In equilibrium, this force is equal in magnitude to the externally applied force. In other words, stress is of two types. Normal stress. It is defined as the restoring force per unit area perpendicular to the surface of the body. Normal stress is of two types: tensile stress and compressive stress. Tangential stress, when the elastic restoring force or deforming force acts parallel to the surface area, the stress is called tangential stress. Now I request you all to please take a look at the graph given on this slide. Strain. It is defined as the ratio of the change in size or shape to the original size or shape. It has no dimensions, it is just a number. Strain is of two types. Longitudinal strain. If the deforming force produces a change in length alone, the strain produced in the body is called longitudinal strain or tensile strain. It is given as volumetric strain. If the deforming force produces a change in volume alone, the strain produced in the body is called volumetric strain. Shear strain. The angle tilt caused in the body due to tangential stress expressed is called shear strain. It is given as the maximum stress due to which the body can regain its original status on the removal of deforming force is called elastic limit. In this slide, now we'll be discussing the Hooke's law. Hooke's law states that within elastic limits, the ratio of stress to the corresponding strain produced is a constant. This constant is called the modulus of elasticity. Young's modulus. For so In this slide, we'll be discussing regarding the stress and strain curve. I request you all to please take a look at the graph. Stress strain curves are useful to understand the tensile strength of a given material. The given figure shows the strain curve of a given metal. The curve from O to A is linear. In this region, Hooke's proportional limit law is obeyed. In the region from A to 6, stress and strain are non-proportional. Still, the body remains its original dimension. Once the load is removed, point B in the curve is yield point or elastic limit, and the corresponding stress is known as yield strength of the material. The curve beyond B shows the region of plastic deformation. The point D on the curve shows the tensile strength of the material. Beyond this point, additional strain leads to fracture in the given material. Now let's discuss about the Young's modulus. For a solid in the form of a wire or a thin rod, Young's modulus of elasticity within elastic limit is defined as the ratio of longitudinal stress to longitudinal strain. Bulk modulus. Within elastic limit, the bulk modulus is defined as the ratio of longitudinal stress and volumetric strain. Negative indicates that the volume variation and pressure variation always negate each other. Reciprocal or of bulk modulus is commonly referred to as the compressibility. It is defined as the fractional change in volume per unit change in pressure. Shear modulus or modulus of rigidity. It is defined as the ratio of the tangential stress to the shear strain. Modulus of rigidity is given by Poisson's ratio. The ratio of change in diameter delta D to the original diameter D is called lateral strain. The ratio of change in length delta L to the original length L is called longitudinal strain. The ratio of lateral strain to the longitudinal strain is called Poisson's ratio. So, before we end this video, this one we'll be discussing about elastic fatigue and breaking stress. Elastic fatigue, it is the property of an elastic body by virtue of which its behavior becomes less elastic under the action of repeated altering, deforming forces. Relations between elastic moduli. For isotropic materials, thus materials having the same properties in all directions, only two of the three elastic constants are independent. For example, Young's modulus can be expressed in terms of the bulk and shear moduli. Breaking stress. The ultimate tensile strength of a material is the stress required to break a wire or a rod by pulling on it. The breaking stress of the material is the maximum stress which a material can withstand. Beyond this point, breakage occurs. So that's all for this chapter today. I hope you all enjoyed the video. Thank you for watching. Thank you all.